Greetings to the lecturers. My name is Vimal with metric number 176410. My final year project is about carbonization of activated sludge from palm oil meal using superheated water vapor. The raw material for this project is activated sludge from palm oil meal. Activated sludge is the solid separated during activated sludge treatment of pomade from palm oil wastewater, which is high in organic content and can be converted into other useful material. This is the brief process of how activated sludge is produced. First, oil is extracted from palm oil, resulting in the effluent, which is pomade. Pomade is then treated by using aerobic treatment, also known as activated sludge treatment, which produces the activated sludge. Carbonization in this project is done by using superheated water vapor. Superheated water vapor is supplied at 200 degrees Celsius at atmospheric pressure. The advantages of superheated water vapor are it can dry molecules faster than superheated air since the heat capacity of water is higher than air, and it can heat material without oxidation, and finally wet gas easily recovered by condensation. There are three problem statements here. First, the activated sludge disposed in landfill increases the production of methane gas and release it to environment. Second is disposing to landfill consumes huge amount of volume. Third is the activated sludge is not being utilized despite its potential in fuel production. There are three objectives here. First is to develop a new method of producing carbonized fuel from activated sludge. Second is to find the best operational condition of superheated carbonization process by manipulating the temperature, and finally to study about the heating value of the fuel produced. For the methodology, first is to identify the moisture content. Moisture content is important because later it is needed to calculate the yield. If moisture content is not included, then the yield will be inaccurate. First, 10 grams of activated sludge were divided into two portions, which is beaker 1 and beaker 2, 5 grams each. Then it is dried in microwave at 80 degrees Celsius for 1 week. Weight of each sample was measured every day until the weight was constant. Moisture content is calculated by using this equation. Weight of sample before drying is minused with weight of sample after drying divided by weight of sample before drying. Moving on, for the carbonization of activated sludge, 180 grams of activated sludge was put into the rotary kiln carbonizer. The carbonization temperature was set at 250 degrees Celsius. Once the reactor reached the temperature, superheated water vapor was supplied at the rate of 1 ml per minute. The reaction was left for 1 hour, then the reactor was left to cool down. The solid and liquid product produced were collected and measured. This is the rotary kiln reactor setup. The activated sludge was put inside this reactor. Deionized water is supplied to the evaporator operating at 300 degrees Celsius at the rate of 1 ml per minute by using the pump. The superheated water vapor produced is then transferred to the right furnace operating at 200 degrees Celsius and then to the reactor. In the reactor, the superheated water vapor react with the activated sludge, where the activated sludge is converted into gas and flow through the left furnace and finally to the cooling part. At beaker 1 it will be cooled and the liquid product will be collected in beaker 1. The non-condensable gas will then flow to beaker 2 where it is collected by using water displacement method. This is the operating temperature of reactor. First, the temperature was set at 250 degrees Celsius and heated up, which will take about 2.5 hours. The reaction time is for 1 hour, and after that it is cooled to room temperature. The manipulated variable for this project is 250, 300, 350, 400 and finally at 450 degrees Celsius. After the solid product produced, it is analyzed by using three ways. First is yield calculation. The yield is calculated by using this formula, and then finding the heating value using bomb calorimeter, and finally analyzed using CHNS analyzer. This is the result and discussion. First is for moisture content. The weight of the sample for 5 days is as in this table. For beaker 1, we can see that the weight is constant at day 4, while for beaker 2 the weight is constant start from day 3. Then the moisture content is calculated by using this equation where I said in earlier slide, and finally the average moisture content was calculated, which is 72.61%. From here we can see that in the first 2 days the moisture content increases linearly, and then it almost kept constant after day 3. From this diagram we can see that there is no color change after drying, but the volume decreases greatly because 70% of the activated sludge is made up from water. The moisture content was huge because palm oil industry use a lot of water or steam in oil extraction process. All the water were eliminated together with the effluent as pomade. Although pomade was treated with biological treatment, huge amount of water was still with the sludge, resulting in high moisture content. This is the visual observation of the activated sludge. This is the sludge before carbonization. It is in large lump and very sticky. This is the dried sludge. DS means dried sludge, which is not carbonized, and this is the carbonized sludge at 250, 300, 350, 400 and 450 degrees Celsius. As the carbonization temperature increased, the amount of small lump decreased and it was becoming more powder. We can see that at 250 degrees Celsius and 450 degrees Celsius, 450 degrees Celsius was in a fine powder form, while in 250 it is in large solid. This was because as temperature increased, the amount of energy present to break the chemical bond increased, thus producing more powder. This is the yield of carbonization. The initial weight of sample and final weight of sample were measured for different temperature. The yield is calculated by using this formula as I mentioned earlier, and the highest yield is at temperature 250 degrees Celsius, which is 0.939. The overall yield of solid product decreases. This was because at higher temperature, more activated sludge was converted into gas and liquid product, resulting in less solid product. This is the result from CHNS analyzer. CHNS analyzer was used to identify the carbon, hydrogen, nitrogen, sulfur content in the carbonized product at different temperature. Comparing dried sludge and carbonized at 250 degrees Celsius, there is increase in carbon percentage, while others decrease. Comparing when the temperature increase, all the carbon, hydrogen, nitrogen and sulfur decreases. The content decreased in solid product as carbonization temperature increased because they were converted into gas and liquid product. From the composition, the atomic ratio hydrogen to carbon and oxygen to carbon were calculated. From the ratio, Venn Cravelen diagram is plotted. It is to identify the process involved in the carbonization process. In this direction, which is to the downward and left, the process involved is dehydration, while this direction, which is to the right and downwards, is demethanation. This resulting in production of liquid and gas product. Other than that, we also can identify the carbonized sludge is in which type of coal. From the literature review finding, I found that it is closest to the lignite type coal. Heating value is calculated from the CHNS analyzer by using this equation, where heat generation is like in this table. Lower heating value is calculated from the composition of CHNS analyzer for single element, and then the total lower heating value is such as this, and from bomb calorimeter the higher heating value is such as this. From this graph, we can see that the higher heating value increased after carbonization at temperature 250 degrees Celsius, which is almost to 14,000 kilojoule per kg. And as the temperature increased, the heating value decreased. This was because all the carbon, hydrogen and nitrogen content decreased. The heating value of lignite coal was 16,000 kilojoule per kg, while heating value of carbonized activated sludge was almost to 14 kilojoule per kg, which was the best at 250 degrees Celsius. Moving on to the liquid product produced, the volume of liquid product produced increases as the temperature of carbonization increase. Maximum at 450 degrees Celsius, which was 27.5 ml. This was because more organic compounds from the activated sludge converted into liquid product as the temperature increased. This is the color observation of the liquid product, where we can see that the color becomes darker as the temperature increase. This might be because the concentration of liquid increase, most concentrated at 450 degrees Celsius. Finally, the conclusion of this project is the yield of solid product decreased when the temperature of carbonization with superheated water vapor increased in 1 hour reaction time. The lower heating value of the carbonized product showed maximum at 250 degrees Celsius, which was 13,679 kilojoule per kg. And finally, to produce the best fuel with best heating value, carbonization process should be done at low temperature, as in this experiment at 250 degrees Celsius. For the recommendation, the carbonization process using superheated water vapor can be improved by increasing the reaction time to 2 hours to ensure the carbonization is complete. Carbonization reaction should be done with equipment where the rotary kiln reactor does not needed to be detached, where the samples can straight away put in the reactor. And finally, the rotary kiln carbonizer should be placed in a closed area with suction hole to prevent the gas produced during carbonization doesn't affect the people and surrounding. So that's all from me. Thank you.